Checkers and wherever you shop. Oops, I actually forgot to switch on the recording. My sincere apologies. I will, at a later stage, just repeat these couple of slides. Thanks for whoever started it for me. And okay, so that's the logistics side. There's a lot of our students that end up in the financial industry because there's a lot of technology that is introduced inside the banking system. If you swipe your credit card somewhere at the shop, you don't really care whether that company banks with the same bank as where you are. So how does that transaction hit your own bank account? How do you make sure that the correct amount gets deducted from your account? And there's a lot of IT involved, there's a lot of business process, but then very often there's a lot of people that get around the table and actually balance the transactions between the different banks in terms of who owns whom. The process is involved from when you, let's say, apply for a new loan until you actually get the loan into your account. How do you manage the risk? How do you identify which are customers worth giving financial assistance to? How do we make sure that that process runs as efficiently as possible? In all those in the financial area, there's quite a lot of industrial engineers working in there as well. In telematics and insurance, telematics is where you actually track the data of vehicles and people in real time. You've probably seen a lot of insurance houses that will now tell you that you have a safe day or that you are going to pay more for your insurance because you're a little bit of a harsh driver, you do harsh braking and quick acceleration and you're swerving a little bit too much. Our research group has actually been involved in some of the insurance houses to do some of the data analytics, and we've published this in international literature because we study from a business and a behavior point of view. We can study how people respond, and we study their behavior by looking at huge amounts of data. So in the insurance industry, you find a lot of industrial engineers also in consulting. And what we mean with that is you don't have one place where you work. You work for a company, but your company does projects for a variety of different industries. So this month, you might be working in the banking industry, and next month you have a new client in the mining industry, and then you move over to Sasol and you do some work with them. And in the meantime, there's a small manufacturing plant, and you get to split your time among many clients. And that's typically what we refer to as consulting. And the reason why we find so many industrial engineers in that area is also because many companies cannot afford to have a dedicated industrial engineering or an optimization team employed. So they just bring the consultants in as and when basis. So you go in, you help them fix the company, make it more productive, and then you move out onto your next project. And this actually links very well to Anina's question, can industrial engineers start their own business? Absolutely. I often say we lose a lot of our industrial engineers to private practice or to the private industry because they go and study their own, or they go and build their own companies. They spend 4 or 5 years learning how to design good companies. Why not build your own company? So a lot of these consulting companies that we see with industrial engineers were created by industrial engineering professionals. There's a lot of our industrial engineers that end up going back to farms or starting up new farms because the agricultural area is also an area that needs a lot of productivity improvement. And that's why I absolutely love industrial engineering as a profession. I used to be in the manufacturing environment. I then moved into a consulting area, and only later in my career came back to the university to pursue research as a career. But the sheer spread of exposure that you can actually get in terms of different industries and different parts of the economy is really fascinating. And if you speak to industrial engineers, you'll very quickly pick up they love what they do. I think it's one of the disciplines where often when we get together, we try to understand, but why is this? And I don't have a quick answer, but industrial engineers typically love what they do. Sharice asked, Pretoria University qualification accepted internationally in this course? Absolutely. We're the oldest industrial engineering school. We are accredited by the Engineering Council of South Africa, which means that we're a signatory to the Washington Accord, so you can go to any country overseas and study further or go and work elsewhere. This coming Tuesday, I have kind of a YouTube channel where I interview some of our alumni specifically related to simulation and the teaching that I do with our undergraduate courses. And this following Tuesday, I'm having an interview with a lady, Gerda Trollop, one of our former students of about 10, 11 years ago. And she's currently a professionally registered engineer in Canada. She finished her studies here, hadn't got an opportunity to move abroad, and she's over there. Many of our industrial engineering graduates move on to go and study abroad. And our South African students are typically loved internationally. They are hard workers. They are exposed to a lot of diversity. And this is really great. We don't often appreciate that of South Africa, but we're exposed here to a lot of different things that give us a really interesting worldview. And the international top UNSLR and Georgia Tech and TH in Zurich, really some of the top schools love having South African students to go and study there. So once you've got this degree, it is accredited and it will definitely remain accredited for the foreseeable future. We've got a great complement of staff, really smart people that will be looking after you for your studies. You see where us on average how large are classes for this course. In industrial engineering, this year we had about 130 students in our year group. It varies. I believe in one of the upcoming years, I mainly teach at third year level. We have a smaller class that will roughly be, I think, about 100, but typically nowadays we're looking at about 100 to 150 students. And all of the venues, even our computer laboratories, if we do get back onto campus again, all of our computer laboratories are able to cater for all of those students in a single session. We've got beautiful large auditoriums. And now during the lockdown period, a lot of our courses are, well, all our courses are currently running online. So we've got really flexible and agile infrastructure to look after you no matter what the environment throws at us. You see where I'm at? Okay, so I'll answer that question, the class sizes. Anina, is it a problem if I did not have IT as a subject in school? Not at all. If it really was a prerequisite, then the university would have listed it as a prerequisite. The same with financial accounting. In your fourth year, here on the screen, you can see you need management accounting. And in your third year, you actually have accounting itself, financial management. And also, you don't need to have accounting at school. I think what is important is that you attend class. And I think that holds for any tertiary degree, but especially in engineering. Because what happens very often, and I remember this from when I was studying, is that the students who did have accounting at school attended the first lecture and said, oh, we did this in grade 11 and 12. And then for the next couple of weeks, they didn't attend. But in the lectures, they went through the matric materials so quickly and then built on top of that. But they do take into account that you are coming from a point where you may not have accounting as a subject at school. And then the guys that did have accounting actually falls behind because they didn't attend class. So rule number one is attend class. They are there for a reason. And if you stick around and pull your weight, then the curriculum will definitely look after you. And the same with programming. When we introduce you to programming in your second year, let me just go up there. This is third year programming and information technology. Students at this point are taught Python, which is probably different from what the school curriculum currently teaches. And you will not become a professional programmer. That's not the idea here. It is to teach you some of the basic principles of good programming practice and just engaging with programming and information technology in general. Danae asks, what is the YouTube channel? You can just search for Johan W. Joubert. It's under my name, and you will see my picture pop up probably somewhere. Or if you search for simulation and you search for industrial engineering, you will see a lot. You will actually see a lot of our course material on there. And you're more than welcome to comment or have a look at it and get a feel for what we actually do. Or just get a feel for what some of our third-year students are currently experiencing, because those are some of their lectures are on there. So for the purpose of the recording, I'm just going to repeat these few slides if somebody else wants to look at them later. So in your first year of studies in industrial engineering, the majority of your effort and modules will be around general engineering, so the electricity, electronics, material science, mechanics, which all engineers will have. No matter what discipline you're studying, these are the modules that you will have. The same with maths, calculus, linear algebra. You've got your basic sciences, physics and chemistry, and you're introduced to social sciences as well, because even as engineers, we need to deal with people. You will be introduced to communication. How do you communicate using graphics? How do you design? How do you build good presentations? And from your first year already, you will be exposed to workshops and to practices, because every engineer must weld, and every engineer must be able to work a milling machine and a lathe at some point, even if it is just for the fun of it, to be able to say that you've done it. Not all engineers strip a Volkswagen Beetle in their hostel room, contrary to popular belief. The fact, and you probably had that question if you consider studying engineering, is whether you'll fix your uncle's car while you're studying. Right, so not all of us are mechanics, unfortunately, but you will be exposed a little bit to workshop practice and medical certificate for call it can't remember the name right now. A medical certificate that first aid. There you go. Thank you. First aid qualification at the end of your first year. In your second year, the general engineering is still the dominant part of your curriculum. You'll have dynamics, manufacturing, design, engineering, statistics, and thermodynamics. Again, modules that all of the engineering departments students will take. You have some more maths in your second year, and this is the first time that you're introduced to industrial engineering, productivity, professional and technical communication, because industrial engineers is very often the glue that brings other disciplines together. You will bring the mechanical engineer who's responsible for maintenance and design. You'll have the CFO, the Chief Financial Officer, because he needs to find the money for the new equipment. You will have the legal people there because they need to look after the environmental regulations. You might have somebody from the labor union there. So the industrial engineer is the translator to bring all these professional disciplines together, and you need to be quite competent with that. In your second year, we also introduce you to programming. This is not so that you can design software per se, but that you actually learn how to engage with a computer to get stuff done. You've heard in many of the presentations, everybody talk about the fourth industrial revolution and big data. All that means is we generate huge amounts of data, and how do we actually make sense of all this data so that we can make better business decisions. So that's what we will teach you and introduce you to in programming. And then there's a community-based project that all students engineering students are required to complete. Because you're not just an engineer, you're a citizen of this economy. And that means you need to involve yourself in the community. That's just good citizenship. In your third year, this is where the bulk of your work will become industrial engineering. So we look at manufacturing systems specifically, but then we also look at operational management, which is much bigger and wider than just manufacturing. It's any operations. You will get exposed to the services industry, the health industry, the just corporate environment, mining, anywhere where there are business operations, you are likely to find industrial engineers. Operations research, industrial analysis are the more quantitative, model building, data heavy, in my view, cool Tools in industrial engineering. Clearly, I'm biased. That's my field of interest. We will look at industrial logistics, which is the trucks and the movement of goods and services between geographically dispersed places. All companies run some form of an IT system, and all this data that we gather in the economy are residing on information systems. So how do we engage with these? How do we design them properly so we can access the data and make, again, good business decisions? We will look at simulation modeling. This is also what I showed earlier in my presentation. Prof. Einstein referred to this as a digital twin. How do we imitate reality so that we can play around in the same environment before we actually implement the real changes into practice? So we do what-if type of scenario analysis just to make sure we understand both the intended and the unintended consequences of our changes. We look at facilities planning. Where do you put a good, what is a good place to put a company so that it's close to its material suppliers as well as close to its customers? How do you design the facility so that there's good flow of goods and services through the plant? So you'll be exposed to all of those aspects. General engineering still is part of your curriculum. Engineering management. We will all have to manage people or departments or machinery at some point. How do you do that in an ethical, sound, and efficient way? You will be learning and working with other engineering disciplines in one of your group work modules as well. And this is where we become really industrial engineers. We look at the business side, and that also means that we need to look at business law, which you introduced to in your third year. You'll not become a lawyer, but you need to understand enough about business law to understand how companies do business and how do they move around, what they can and can't do. You will have some more practical training in the industry, and you will be introduced to financial management. You don't need accounting at school. Everything will be covered from the basic principles. Again, you won't become an accountant, but you will know enough to be able to talk the right language when you need to sit with an accountant around the table to make engineering sound decisions. In your fourth year, again, the bulk is industrial engineering. You've got some more operations research, which is a quantitative module. Quality assurance, here's the business engineering, because if you can design a machine, or you can design a mine, or you can design a road and a bridge, then you can design a business as well. So this is the business engineering. How do you design a good and sound business? And the phrase that we often use here is we balance man, money, and machine. Yes, you're an engineer, you're interested in the machine part, but a business is also about the money and the man. And this is not gender specific. Man just being the people involved. We don't automate everything. We would like to believe that we're going in that direction, but people will still be involved. And how do we involve them in a sustainable and ethically good way, so that your people don't get angry at you and walk away and close down your business. But it needs to be or be financially sustainable and make business sense as well. So man, money, and machine needs to be in sync. Systems engineering, you will learn how to put these building blocks together, and then some more engineering economics. Your capstone in your final year is your industrial engineering project, where you get to go out and work on a single project from start to finish, identify the problem, decide what the best course of action is in terms of designing a solution. Maybe it is an investment solution, a money person, a redesign, technology. Maybe it is a simulation model. Maybe it's just process improvement. You get to kind of put your fingerprint on there. And this is a very rewarding project for the majority of industrial engineers. This is really your capstone. You do some more financial management accounting, where you learn how to evaluate the company financially. Is this a good investment? If I need to take over a smaller company, is this the right buy, or should I rather go and look for someone else? How do you evaluate the company? Because your own company will also be evaluated in that way. So you learn how to measure in more ways than one a business. Some more practical training. You still have general engineering. like engineering professionalism, because you are still a professional that needs to engage with other disciplines and engage with the public. We will also introduce you with labor law. Again, as I said earlier, it's no use you design beautiful things, but you don't look after your people on the shop floor. They will get angry and they may even sabotage your machinery. So how do you deal with that? But how do you actually avoid it to start off with? We'll introduce you to some labor relations. And that's in a nutshell your 4-year curriculum in industrial engineering. And then as a question, do you know when the university will start next year? Anina, do you know when COVID will be over? I guess not, and unfortunately I have to say here that I don't know either. What I do believe is that the university will most probably look at creative ways of accommodating grade 12 students, knowing that your matric results are likely only to be available towards the end of February, if I'm not mistaken. I think something like 23rd. So good luck with that, but we won't leave you behind. It's probably all I can say. But unfortunately, we don't know. We make this up as we go on as well, and we try to be as responsive to whatever we get. But you can rest assured, the university will leave people behind for an entire academic year. We will wait for you. We will be here. Then I ask, does industrial engineers have a hand in the process of plant growth to medicine production? A couple of years, about 2 years ago, I had a group of students in my simulation module that did a semester project where students get to work in groups. And they did a project in the timber industry where they grew, or they wanted to decide from the point when you plant trees until you can harvest them, that's about 35 years. How do you thin out the trees? So you start off by planting a lot, and then as they grow up, you actually thin them out and you pluck some of them, and later on you chop some of the smaller ones down, and you only end up with a whole bunch of larger ones. So from a plant growth point of view, absolutely. In agricultural crop rotation, you see a lot of industrial engineers in that field. There's actually quite a number of, well, I know of a couple of industrial engineers that are also involved either in their personal or in professional capacities in aquaponics, where they grow greens in enclosed systems along with raising fish, where the fish poop becomes the food for the plants, and it's a closed circuit or closed system. So the nice thing about industrial engineering is you can really play to your own strengths, and I think that's our message as well. Is you need to find something that you can do for the rest of your career. I mean, yes, you're going to work, but nobody said it has to be ugly, right? So you really can get to love what you're actually doing. You need to find your passion in the process. Now, passion is not something that you just pluck out of thin air. It also comes with training, and you will become passionate about the things that you actually learn or what you study. So I'm not too worried about what your choice of engineering is. What I am interested in is that you throw your weight into whatever you choose. And in the process, you will become passionate. If you give it the necessary attention and interest, it will definitely become your own passion over time. Be it then moving into medicine. I know of a couple of industrial engineers that used to work in the pharmaceutical industry, not so much in producing the medicine in terms of designing new medicines, but definitely in the production facilities. Those are very peculiar facilities in terms of the requirements of cleanliness, the quality assurance that are required to make sure that every pill that goes out of that plant, you can trace back to who had their hands on it. So the rigor with which you need to design those processes are really, really critical. And industrial engineers are very often involved in helping those companies design processes to be reliable, not just now, but in the future. And that's what we mean with quality assurance. not just quality now, but I can assure you that the quality tomorrow and next year will be very consistent going forward. What do the postgraduate studies involve? Joshua, great question. This is where the real fun starts. So, and that is why the first degree, your undergraduate degree, really gives you a wide exposure to industrial engineering. That's why you get exposure to operations research, to business engineering, to engineering economics in your third year, to simulation, to operations management, to manufacturing. It's a very, very broad field. And in postgraduate studies, you actually tend to focus a lot more into a discipline or a sub area that you really like. At our university, we first do an honors degree, which depends on how you choose your modules, is anything from 4 to 6 modules usually, and those I would argue you pick with the help of a supervisor that you've kind of built some track record with, somebody that you really want to learn from. And now you can actually start getting expert content on a particular field. So now you don't work as wide, you work a lot more narrow, but you've got a lot more choice in terms of the modules that you take. So in our department, we focus a lot more on logistics, on simulation and operations research, and information systems and design, or what is also referred to as business architecture or business engineering. And those are probably the core focus areas of our in the honors program. You also do, similar to here, your industrial engineering project, you also do an honors project, which is really very nice, where you can start immersing yourself. And if you pick it correctly, then this honors project of yours can also lay the foundation for your master's degree. Now, in our department at our university, the master's degree is by research only. This is really where you become a master of a particular topic. So you find the topic or scope the topic with the help of a supervisor, and you work for an entire 18 months, anything from 12 months to 24 months on a single project in terms of really mastering that field of industrial engineering, and that then lays the foundation to move into a doctorate, or what we call a PhD. Which is also research-based and then focuses on, again, even smaller, more specialized area within industrial engineering. So our journey in the postgraduate is honors, masters, and then a PhD. All right, you're welcome to type your questions in the chat box. I think I've covered all of them. And let me just check in terms of the attendees, where I can see any hands up.
I think that we can wrap the session up. I've been monitoring it, but I don't see anybody else joining the session. Almost all of our disciplines have closed already, with the exception of mechanical and civil engineering.
You're welcome. We can close the session. I don't have a problem.
Okay, fantastic. Professor, thank you again for all your time, and I hope that the students derived value from your answers to their questions.
Great stuff. Gilad, thank you very much. Have a good weekend.
Fantastic. Same to you. Bye-bye.